Okay, so as soon as you get your envelope, open up, have a little look at the cards.
These students are developing their skills in reasoning and mathematical proof. They have been given a set of cards with statements on them. They are to determine for each statement whether it is always true, sometimes true, or never true.
As a student found an example of when this worked.
In this video, the teacher also discusses what he learned from using the activity with his students.
If the digit sum is a multiple of 9, so then 2 times 3, so 9. Then the number is a then the number. So is that right then or not?
I'm not sure. Adding two numbers and then squaring gives the same result as squaring and then adding.
I thought students tried really hard at this. There's lots of work on their A3 little sheets. You could see they were all trying little numbers, and you can see that there was actually discussion, and they're able to really kind of back up why they put something in that category. You know, you could see they were like messing around with the cards and having discussions, and somebody was saying that should go there and that should go there.
The sum of 3 consecutive numbers is a multiple of 6. 2 plus 3 plus 4. That'd be 9, but that's not. That's a multiple of 3, not 6. That'd be 12, which is also a multiple of 6. So you could say that it's sometimes true, but not always.
Well, I think what's really good with activities like these, especially the more algebraic ones, is students can just try it with a few numbers, and then they can also work with somebody else where, you know, somebody kind of maybe tries a different number than the other person, and they kind of build a little bit of a bank then, whether this is working all the time or some of the time. Then I think really it's just the next stage, just kind of encouraging students just to, you know, is to use the algebra. And this is why I do like the sum of the 3 consecutive numbers is because it's really, there's not many steps, but it does work really nicely.
Would you pick particular ones as a detailed example for them to look at?
There's one about the product. Adding 1 to the product of 4 consecutive integers gives a square number. Now, lots of these proofs I've seen before, but I hadn't seen that one. I really, really liked that one. And when students were working away at these, I wasn't sure whether that was an always or a sometimes one. I think that would be a really interesting one to look at because you'll end up with quite a tough power for students once they start looking at the algebra.
And all the interior angles there add up to 360, but in a triangle they add to 180. So none of them angles are equal, but they can't be higher than 90.
This one here about the angles in the same segment was a case in point where the students found it difficult to explain why.
It works because of previous circle theorems, this one, so it is quite a difficult thing, especially if students haven't done this before. The one that I particularly like was adding 2 numbers and then squaring gives the same result as squaring then adding, because as you know, a common mistake that students make is they think that x plus 1 all squared is just x squared plus 1 squared, and then they forget about the little 2x in the middle. What I enjoyed about the lesson today is a student found an example of when this works, and it was pretty much the only example that I could think of. The rest of the time, obviously, it never does work. Where did you put it?
Sometimes true.
Sometimes true.
If you do 0 and 1, if you square 0, you get 0. If you square 1, you get 1, and add them together, you get 1. And if you add them both together, you get 1 in the square root. And then if you square 1, you get 1.
The sum of 3 consecutive numbers is a multiple of 3. Where did you put that one? You know, I think sometimes with this work, students get a little bit scared of it. And it's sometimes very difficult to start, isn't it, I think, this work. And I think, you know, working with a partner in that regard, it just means kind of, you know, 2 people working together. It'll just allow students to get a bit further.
There's also the issue of most of these statements being written in words.
Again, that is something students do struggle with, and if they do start being drip-fed little bits of information and they do start with something quite comfortable, I do think students can work really from something quite basic to something quite, you know, quite nasty, like the adding 1 to the product of 4 consecutive integers.